In the data center, we use Ether channel because it offers many advantages. An Ether channel or port channel is often used between the switches in order to increase the capacity of the connection between them by performing load balancing of frames traversing the Ether channel. Load sharing or balancing is based either on source or destination MAC address of the transmitting computers when the layer 2 Ether channel is used. This can also be changed to use other parameters as well. In case of an active link failure, the next link is going to transmit the packets with almost no delay. Keep in mind that the word Ether channel is a Cisco term. The industry standard name is link aggregation, or IEEE 802.3 AD. In a modern day network, you may see multiple links going to multiple devices, such as we have here. By using an Ether channel, we can take these 6 links and actually turn them into 3 logical links. This would increase our availability and bandwidth in the network, as well as reduce the number of links that are blocked by spanning tree in our environment. Cisco offers you 2 ways of configuring an Ether channel or a port channel on a Nexus device. The first way is with dynamic channel negotiation using the LACP, or Link Aggregation Control Protocol, which is an industry standard implementation. The second way is to manually configure the links to be in a channel without using any form of negotiation. Once again, the benefits of using this technology in a data center network is that in a normal situation, these 2 links going between these 2 switches would cause a loop. Spanning tree would then block one of the links to avoid the loop condition. By grouping these 2 links in an Ether channel or a port channel, we make them appear as one, therefore avoiding the loop situation and allowing us to use the full bandwidth between the switches. If you would like to configure an Ether channel using LACP on an NXOS device, you have 2 mode options. The first one is active. In this mode, the ports are actively sending negotiation frames to the other switch, checking if the required parameters match and if the channel can be safely formed. The second mode is passive. In this mode, the ports are waiting for the negotiation frames from the other switch in order to form a channel. The ports in the passive mode do not initiate any negotiation like they do in the active mode, but they will reply to the negotiation frames if they were received from a neighbor. If the parameters between ports on 2 switches are correct, the speed, duplex, trunking, VLANs allowed, etc. are the same, the following channel modes will succeed in forming an Ether channel. If one switch has active and the other switch has active, they will form a port channel. If one switch is active and the other is passive, it will form a port channel. If both switches are passive, the Ether channel will not form because both sides will be waiting for the other switch to start a negotiation. It's imperative that you check all the settings of the ports first and make sure that they are identically configured. Candidate ports must also be in the shutdown mode. This precaution is used to avoid loops and other issues while establishing the Ether channel or port channel. Please join me for the next lesson exploring VPC and its components.